rectify on the chat session. Okay. So before we go into analyzing our data sets, we'll be analyzing this ETS data set. We'll be looking at EDA proper. But before we go into that, I would want us to, talk briefly on understanding exploratory data analysis on healthcare data. Because when we are talking about data analytics or healthcare data analytics, EDA is a major aspect of data analytics. It encompasses most aspects of data analytics. And if your EDA is detecting error in your insight, in your derived insight, okay? So that's why EDA is a very important aspect of data analytics. So today we'll be looking at understanding exploratory data analysis on healthcare data. So what is exploratory data analytics, and or what is EDA as is mostly referred to? Exploratory data analysis is the process of analyzing data sets to summarize their main characteristics using statistical graphs, tables, and visualization. Most of the times, if you've watched my video, if this is not your first time you are here, and you've watched any of my previous video, you will see that before we go ahead to um, analyze any data set, I usually carry out an intensive exploratory data analysis where we have to, it encompasses both data cleaning, looking at what your data set is all about, trying to get some insight and find this input before you go into the main analysis of that data set. So EDA is very important because most of the times you look at the steps of EDA, that's where you are going to identify if you are having if your data set is faulty, if you're having a faulty data set, if your data set is consisting of many outliers, many missing values, it's at this phase you are going to find that those issues or faults in your data set. So exploratory data analysis is the process of analyzing your data set to summarize their main characteristics. For example, if you have a data set and you have an age column, you can be able to find out what is the average age in this data set, what is the maximum age. Imagine a data set where you are having a maximum age of 200, then you should know that that 200 years as an age should be analyzed, because is it possible in our current time of having a patient that is of that age? I know there are chances where it might be possible, but it's going to be questionable. So you have to go back and ask, is this value real? Is it correct? Was it supposed to be 20 and it was mistakenly filled in as 200? So this is where you go ahead and ask questions. And if you don't analyze your data, if you had not used the dot describe method and see, okay, what's the minimum age in this data set, what is the mean age, what is the maximum age, you will not be able to find out that you have an age value that is of about 200 years of age, right? So EDA is very, very important when it comes to analyzing data, not even healthcare data, any data in general. EDA is a very, very important aspect, because EDA is used to understand data patterns. That, like what I've been saying, you can use EDA to understand the pattern of your data. Is it a normally distribution data set or it is not? You can use it to understand relationships between columns. What's the relationship between age and a patient being readmitted into the hospital? You can use it to look at relationships. You can use it to detect abnormalities. You can use it to identify outliers. You can even use it to test hypotheses, because when you see some certain things that are in your data, after analyzing it, then you can decide to write out an hypothesis to confirm these things that you have discovered or you have uncovered in your data set. Especially crucial in healthcare for uncovering trends, ensuring data quality. Like I've been saying, data quality. Because if your data is having errors, if your data is having missing values, if your data is having outliers, then there is high chances that your insights you are deriving from your data, it's going to be wrong. Okay, so to ensure that your data has quality, high quality, you have to endeavor that that data set goes through um EDA. It has to go through exploratory data analysis for you to find out these faults in your data. Remember that there's no data that is 100% clean. There's no data set that is 100% perfect. You have to explore, you have to clean, you have to work on that data set to get a quality data for you to analyze, for you to go ahead and analyze. So the next thing we'll be looking at is importance of EDA in healthcare. Why is exploratory data set very important in the healthcare sector? It is to validate data quality and completeness, because and the healthcare sector is a very, should I say, technical or fragile space. You are not just dealing with business values, you are dealing with lives of patients, you are dealing with lives of individuals, right? These your findings and insights are going to either improve the life of individuals, of patients in that hospital, or improve the quality of care that is being rendered by that hospital or healthcare system or healthcare facility you are conducting this analysis on, right? So if your data set is not of quality, if your data set is having issues, if your data set is not, if you are not using the right data set, your findings are going to be wrong. And if your findings are wrong, then you cannot improve your quality of care you want to give to the patient. It means that those your if your findings are wrong, the quality of care that you are supposed meant to be giving to patients is not going to be improved, right? Because you've given wrong findings. Another importance of EDA in healthcare is that it helps to identify trends in patients' demographics, diagnosis, and treatment. For example, if you have a patient data set or if you have an hospital data set, you can be able to identify from which region, from which neighborhood. Like our last data set in our last Saturday webinar, we looked at a data set where we were exploring different diagnosis or disease condition from patients that were coming from various neighborhoods and patients who were likely to miss their appointment or not. So analyzing that data set help us to identify that, okay, patients from a certain neighborhood tend to miss their appointments or not. Okay, so that's what EDA helps us to uncover. So imagine that I explored this data set and I was able to find out that patients who had a booking, probably a 2 days or a 3 days earlier booking, and they were living in this certain neighborhood, most of the times they miss their appointments. You cannot go ahead and analyze what's the reason, what is causing patients in this environment to miss their appointment. EDA in this point has drawn us to a very important insight, and now we are trying to shine our torchlight on that aspect of it, right? So that is one importance of EDA. It helps us to be able to identify trend in diagnosis, what is happening. Yeah, analyzing an healthcare data set, and probably in the hospital for a period of time they've been a readmission patient has been who were attended to, who were treated and discharged, are being readmitted back into the hospital. You analyzing this data set and you can decide to find out, okay, what's happening. Is it that there is a spread of probably in the hospital was making patients break down and be readmitted back into the hospital. You can, and even trends in patient treatment. It's another importance of EDA in healthcare that it supports decision making, because this is the main idea of analyzing any data set at all, even a business data. The main idea of employing a data analyst to analyze the data set is because you want to be able to use those findings and insights to make decisions, either in your business, either in any institution at all. So EDA helps to support decision making and policy development. It also helps to prevent data misinterpretation. Once you are I told you that a very important aspect of EDA is cleaning your data. So if you can clean your data very well, or during the process of cleaning your data, you're able to find some things in your data set and you're able to say, okay, we need to go back to our source of data and really confirm if these values are true. So that's a very important aspect of EDA. When we are going through our projects, you see some of these things that I'm talking about. So the fourth slide here is typical healthcare data sources. Where are the source or areas where we can get our data sets from? We have electronic health records. Most hospitals these days have a database where all patient data are being saved. Healthcare data is very cumbersome. Healthcare data is very cumbersome because you have to collect department, um, patient data from lab, patient data from any other aspect, finance data. There are a lot of data you have to collect about a just one patient can generate thousands of data. Okay, the EHR or the electronic health record helps in housing these data sets. It's just like a database that helps in holding these data sets. Then you can also collect from patient admission and discharge record. You know, at the first entry of a patient into the hospital, you are going to give the patient is going to give his details, where he lives, his shift complaint. That's the reason why the patient is coming to the hospital, signs and symptoms, and so forth. So your patient admission, patient discharge is another area where you can collect data from a patient. Laboratory test results, like I said previously, when you go to the lab, you are going to conduct tests. They are going to give you is going to generate data from those tests you are going to carry out, right? So even your billing and insurance, when you're making payments, survey or another method or way we can collect data from our patients is using wearable device or carrying out survey. You can carry out a survey on an hospital. You can give patients a survey and ask them to fill those information. For example, I know there are some hospitals that they do at the end of the year, the best nurse that attended to you, the best doctor, the best ward we attended in, how clean is the hospital, what's the time range they use in attending to you, how do the staff approach you. Those are surveys that you can carry out, and when the patient gives you their feedback, you can now accumulate this survey and make a data out of it. Even wearable devices like watch, now we have iWatches or even smartwatches that can record health data, your heartbeats, your heart rate, your blood pressure, the amount of steps you've walked in a day. They are wearable devices that you can use to, collect this data and store them. The next key step we'll be looking at, or the next about EDA, and we said EDA is the process of analyzing data sets to summarize their main characteristics, thin graphs, and visualization. And we said this EDA is done to understand data patterns, shifts, detect anomalies, identify outliers, and test hypotheses. Okay, so we want to look at the steps you have to take when you are conducting or carrying out an EDA. The first steps or the first most important step is data collection. You have to collect your data, right? Because the first thing you have to do before starting any data analysis project is data set. You need a data set you want to work on. So you have to collect your data. And previously, we've already talked about various ways or the various sources where we can collect this data set from. It can either be from your EHRO, you can either be patient admission or discharge record, it can be laboratory test results, billing and insurance data, software wearable device data. So these are different ways you can get your data from. So the first step in EDA is collecting your data. This next step after collecting your data, you have a software, a tool you want to use in analyzing your data. For example, we in this case we are using Python programming language and we are using our Jupyter notebook to analyze this data. So after collecting our data, we'll be importing our data set into this our Jupyter notebook to analyze our data sets here, right? So that's the first step, data collection and import. The second step is data cleaning. And data cleaning is like one of the most important step when it comes to analyzing your data set. You have to clean your data. Most data sets are very messy, and data set is like one of the, should I say, the tedious aspect when it comes to EDA, because if your data set is not clean, then you are going to be giving wrong insights. And sorry, excuse me. And this is something you don't want to do, okay? You don't want to give wrong insights in your data. So data cleaning is a very important aspect. The third aspect is descriptive statistics. You want to carry out descriptive statistics of your data. Next is, when we're talking about descriptive statistics, you are going to be seeing how we'll carry out descriptive statistics when we'll be looking at our project, okay? Then the next thing we'll be doing is data visualization. We want to, we, like we said earlier, we'll be using graphs and tables or statistics in analyzing these data sets. So the next aspect is data visualization, because when analyzing your data, not everybody are used to tables, figures. That's you creating a chart, you creating a bar chart or a pie chart or a scatter plot just makes it much more easier for anybody to understand. So descriptive data visualization is another key step in EDA. Then we have feature engineering and hypothesis generation. In our today's project, we'll be looking at just the first step: data collection and import, data cleaning, descriptive statistic, and data visualization. We'll be looking at feature engineering, but since we are not going to be we will not be creating models, will not go very deep into feature engineering. So we'll just be looking at the surface. Then for hypothesis generation, we'll not be looking at hypothesis generation today, but there are some projects which I've worked on in my healthcare data analysis playlist where I talked about hypothesis generation. So if you want to know how to go about hypothesis generation, then you can look at that. You can watch those videos on hypothesis generation. Okay. So for our next slide, we'll be looking at, that's the first, we said the first key step is data collection and import. The second key step is data cleaning. So we'll be looking at talking about data cleaning. What are those things you do when we're looking at data cleaning? Handling missing values. Missing values, handling of missing values is a very important aspect in EDA, right? Because there are times your data set will consist of a whole lot of missing values, or at times it's just going to be 5% missing values. You're going to decide on what you want to do depending on how many missing values you have in that your data set. If it is much, you can decide to, and drop those columns of data with missing values. If it is if it is not much, you can decide to just drop those columns of values with missing values. If it is much, there are different other methods you can go about that. You can impute those missing values using the mean. You can use the mode if it consists of categorical data. You can use mean, median, mode. It just depends on the if it's a numeric or a categorical data, and you decide on what to do. You can also decide to drop your data set, like, or drop columns that contains missing data, like I've said earlier. Another data cleaning is standardizing data types. There are examples where your age values, let's say 1, 2, 3, 4, age of patients, can be coming in as a string, and those values are supposed to be integers, right? So you have to change those data types to the correct data types. Another example, it can be date, admission date of patient. Instead of it to be in the date format, it can be filled in as a string or as an integer. You have to change those values to date data type format. Another thing is checking for unrealistic values. Like what I said earlier, imagine you analyzing a data set and you have um, a patient age that is above 200 years. It is rarely possible, but those are situations you have to look into to ensure that this is actually a correct data set, because it might be a mistake that the person who wants to input that value was supposed to input 20 years, and the person inputted just added another zero and it was 200 years. So you have to make sure that those analysis is correct. You have to make sure that that value is correct and that value is not an outlier. Because if that value is an outlier, definitely is going to, affect your analysis. For example, if let's say you want to calculate the mean age of a column and you have an outlier of 200 years, it's going to definitely affect your mean value. That's your average value, right? So that's another reason why you should check for unrealistic values and handle them. Another thing is handling noise in critical medical field, and that's what we talk about, missing values. And another thing I should tell you, that when you are working with medical data, not all missing values are missing values. That's why you need to analyze, you need to go back to the source of that data and check, is this actually a missing value? Okay. For example, you have a field called discharge column, and your discharge column occupy is going to definitely occupy dates when a patient was discharged from an hospital, right? What about is in a situation when this patient has not yet been discharged? Then that column is going to be empty. So if you now decide to say that, oh, because that column or that row of data is empty, it means it's a missing data, then you're going to be dropping valuable data from that data set. You can see then you're already making an error already, because that patient has not yet been discharged. That's why that role is vacant. So that's why I say you have to, go back and ask questions from the source of that data and find out, is this value actually missing or is it not a missing value, and decide on what you want to do with those value. Sorry. Another thing is dropping redundant columns. So for example, we can say we have age columns like that contains 0, 2, 3, 4, 5 different ages, right? We can decide to, if we decide to categorize that column into category and say, okay, we want to have children from 0 to 17 years, then adults will be from 18 to, let's say, 45 years, elderlies can be from 46 to, let's say, 70 years, senior or older seniors can be from 79 to above. Then if you've done that categorizing, then you have to drop your age column, because your age column and that your age categorical column are holding the same information, and this is therefore going to make the age column redundant, right? Because you are not going to make use of that column anymore. So columns like that, you have to drop it. When two columns are, speaking to the same thing, when two columns are delivering or giving the same information, then you just have to drop one column so that it doesn't affect your insights. Another thing is fixing inconsistencies. I always talk about this fixing inconsistencies, because it's something that you can easily outlook, and if you do that, it's going to affect your insights you'll be deriving from your data set. And when we talk about inconsistencies, let's say, for example, you have a gender column, and the person that was feeding in the data into this database made an error, and probably for female, she spelled female as FEMALE, female, and there are other places, let me say, and there are other places she used the word F is. So what I'm trying to say is, okay, um let me go down and see. Let me just add a new slide so that I can explain this. Okay, let's say the person used female, okay, and other places the person used this small letter O, or let's say the person used F in other places, and let's say in other places the person used the small letter um the small letter FEMA. Let's say FEMALE, but this was in small letter. So there are different ways you can spell females, right? It can even be there was an error, probably a typo error, and instead of she spelling female, she spelled it like this. Okay, so you have to look for these inconsistencies in these data sets and ensure you make corrections to them, because if you don't make corrections to them, then you'll be analyzing, you want to analyze the female rows of data, but you already have four different types of females, so you will not be able to get the correct insights from that analysis. Okay. um think okay. Sorry, let me go. Okay, we are in data cleaning. You know, to get the correct insight from that analysis. And the last thing is deriving metrics. We've talked about how you can derive your age category from your age column. You can also derive your average length of stay or the length of stay of a patient. Length of stay is a very important metrics when analyzing healthcare data. Okay, so you can derive that by the date of admission and using the discharge date. So if you subtract the date a patient was admitted into the hospital from the day the patient was discharged, you're able to get the number of days the patient spent in the hospital. And that is a very important metrics when you are working on any healthcare data sets. So the next step, remember we said in our key steps in EDA, we have data cleaning, descriptive statistics. So next we'll be looking at descriptive statistics. And when we're talking about descriptive statistics, what are those things we are looking at? Mean, median, mode, for continuous variables such as age, we want to see the average age, we want to see the average wait time of patients. You know that those statistical values are descriptive statistics. We can decide to say we want to see the frequency or counts, we want to see the count and frequency for categorical variables. For example, we want to see how many males do we have in this data set, how many females do we have in this data set, how many different types of diagnoses do we have in this data set, how many doctors do we have in this data set. So those are descriptive statistics. We can also decide to say we want to see our how our numerical column are being distributed. So we have age values. We want to see the distribution of those age values. Are we having more younger adults compared to older adults? How distributed is this data set? Is it a normally distributed data set? Do we have an skewness? Do we have? Can we find um, any outlier in this data set? An easy way for you to detect outlier in your data set is, looking at the distribution of your data. And when we are analyzing our projects, you'll be seeing how we go about and carry out descriptive statistics on our data sets. So another thing we would look at is visualization. A key aspect of EDA is visualization, because not everybody are okay with tables, figures, numbers. Sometimes it becomes too much that you tend to find it confusing, right? But when you create graph, when you create charts, those are much more easier for anybody to understand, especially when you are creating clear graph or clear charts, very clear charts. Chart that just seeing at it, we able to say, okay, this is what this chart is talking about. This is the insight this chart is trying to deliver. So visualization is a very important aspect when it comes to EDA. You can use bar charts for patient counts. You want to see how many patients has a particular diagnosis. You can use the bar chart or a can chart. You can use pie charts to show distribution. So, for example, instead of you creating a table that says we have 400 patients who are male, 500 patients or 565 patients who are female, you can decide to create a pie chart that shows us these values, right? So imagine you creating a pie chart and we can see that a particular part of this pie chart is shaded blue. A larger part of this pie chart is shaded blue. I can be able to say that okay, we have a larger female population than male population just from looking at this pie chart without even knowing how many numbers are female or male. Okay, you make use of box plot. Box plot is very good because it tells us the minimum, the maximum, the mean value, the median value, the 25% quantile, the 75% quantile value. You can get it even tells us outliers if there are outliers in your column of data set. So box plot is very important when it comes to distribution. You want to look at how a data set is being distributed. You can also use heat maps to show correlation. You can use line charts to show change in values over time. So for example, you want to look at um, the amount of time that is being spent in the emergency room, or how many emergency room visits are you getting over time, over the years. You want to see how many patients have been taken to the emergency room over the years. You can use a line chart to depict that. So the next thing is identifying trends and pattern. What is the whole essence of carrying out an EDA is to be able to identify trends and patterns like seasonal illness patterns, age group that is most likely to miss appointments. In our last week a webinar which we did, we looked at a data set that was all about missing appointments and patients who booked for an appointment and they missed their appointment. So if you want to, look at a data set relating to that, you can check our video. Last week video, you'll see it. Then readmission rates by diagnosis. We'll be doing something relating to that today. Wait time by facility or region. So EDA helps you to be able to identify trends and pattern in your data set. Another thing is feature engineering. Feature engineering in your data set, creating age groups, which we've talked about. You can decide to create categories or groups from your age column. You can decide to combine multiple diagnosis feed into one. So example, you have two different columns and you feel that these two columns will be better if they are combined as one. You can go ahead and do that. That's still an aspect of facial engineering. You can try to look at the time between appointment and outcomes. Like for example, when we're talking about the length of stay of a patient, you can decide to subtract the admission date from the discharge date. That feature engineering is just all about using an already existing column in your data set to create another column where you can get more insight. Okay, so you can even binary indicator for risk factors. There are situations where you can decide to um probably when you want to do modeling, it takes in just numerical values. You can decide to transform your data set to numerical values by using PD dummies and all that. So all these are aspects of facial engineering, and we'll be looking at some critical aspects of facial engineering in our project. The next thing we'll be looking at, what are those tools that are used for exploratory data analysis? Python is a very good tool, and this is what we'll be using today. We'll be using Python to analyze our data. Some people make use of R, some people make use of SA and Power BI. SA and Power BI are data visualization tools. You can also make use of Tableau, which is a very good data visualization tool. So all these are used for carrying out data analysis or EDA on your data set. I think I have a playlist. I have a playlist that is just I have a playlist that is for learning how to analyze healthcare data using Tableau. So if you want to, watch any videos relating that so that you can check on that. Then challenges in healthcare EDA. What are those challenges you face when you're analyzing healthcare data? Like I said earlier, when we were starting this class, I told you that healthcare data is different from business data. Healthcare data, you're working with um lives of patients. Your insight that you are going to derive is to either improve the life of the patients or to improve the care that is being rendered by the healthcare facility, right? So you have to be very careful when you're analyzing healthcare data so that you are not giving out wrong findings. So what are those challenges you face working with an healthcare data. One is privacy and data protection. This data set you are working with is about patients patient information. This patient information is going to be containing the patient's age, the patient's home address, the patient's health condition, the patient lab results, and these are things that the patient might not want to put out there in the public space for anybody or everybody to know. So privacy is a very important aspect in the healthcare space, in the healthcare field. You have to ensure that you are protecting the patient privacy. And to do that, even when you are working with the data set that is being generated from the patient, you have to ensure that those there's data protection and the privacy of that data is being protected. That's why most of the times the patient's name is not going to be on the data set. You're going to be seeing patient ID values, numbers that are used to represent those different patients, so that even when you're working with the data, you don't know which particular patient has any of these records you are working with. Another thing is missing or inconsistent data entries. The patient data set is very large. Like I said earlier, it is very large because you are collecting data set from in as at the first time the patient is setting foot inside the hospital system. Data has already been generated from the admission, from the OPD department to the admitting of a patient, to going to the lab to conduct tests, to going to pay B points to make payments, to going to any scan to go and carry scan, to doctor appointment, to the nurse rendering medication to patients. Every aspect, every point an healthcare professional or any professional in the hospital is having an interaction or a contact with a patient, data is going to be generated. So, and you know that the person that is handling this data set might make error, might make mistake. Me personally, I've experienced it. There are situations where you will see your data or your file, you will see in some places you will see a patient, let's say for example, you'll be seeing 25 years. In another aspect, in another place, probably um a patient file from the lab, you'll be seeing 26 years. Patient file where the patient went to see the doctor, you'll be seeing 24 years. Like one same patient, but different years values. So you have to fix those inconsistent values. You have to make sure that, oh, what's the actual age of this patient? You have to go back and find out the actual age of the patient and fix those values. That's just an example. There might be situation where this patient might be a gender female, and there might be an error probably from the lab and a male was written in that gender aspect. So you have to go ahead and check where is this error coming from, fix those errors. Okay. Another challenge is high dimensional data, because patient record contains many different measurements and observation. One patient is going to have different records because we have different departments in the hospital, right? So one patient is going to generate a patient can just one single patient can generate a whole lot of data, a whole lot of information just from visiting the hospital in one day, because you can go to the OPD. From the OPD, they can refer you to another department. From that department, you go to the B point, you make payments. From the B point to make payments, you might go to the lab to carry out some tests. From there, they might refer you to go um to go and carry out some scan and all that. So from just one entry into the hospital, one particular patient can generate a whole lot of data. Then imagine the influx. Imagine having thousands of patients generating this a whole lot of data sets. So healthcare data sets are usually high dimensional data, and because they are bulky, you might have challenge, or it might be a bit tricky when you're handling these data sets. Another challenge is clinical terminology and complexity. And this is for people that are not coming from the healthcare space, that are not coming from the healthcare field, that they are probably coming from another profession and they want to become healthcare data analyst. That's why I always recommend that you have to, know a bit of this terminologies. Okay, they are not something that are difficult to learn. They are something that when you go to the hospital, they are being used. Like, for example, average length of stay. It's just the difference between the day a patient, how long a patient stayed in an hospital. That's, you can just subtract the day the patient was admitted from the day the patient was discharged. Okay, but if you are not in that field, it might be a bit technically for you to understand. Oh, what's ALOS, or what is average length of stay all about? We talk about readmission rates. We also talk about, there are different things you look at when you are analyzing healthcare data. There are different terminology, like some healthcare conditions that have, there are different terminologies or healthcare diagnosis when you are analyzing healthcare data. And when you are not in that space, you might find it a bit tricky or a bit should I say confusing, but with time you'll be able to, get those things and understand them. But at that point, when you're analyzing that data set and you don't know those things, it's going to be like a challenge to you. So in conclusion, before we go into analyzing our data sets, we would say EDA helps to transform raw healthcare data into actionable insights. It is critical for data driven healthcare delivery and policy decisions, and is also a foundational skill for every healthcare data analyst. Is a foundational skill. Without EDA, without you knowing how to explore and get insight from your data sets, then what are you doing? If you can't clean your data set right, if you can't get insight from your data set, if you cannot explore your data set to get insight from your data set, then what analysis do you want to carry out on that data set? Okay, so this brings us to the end of this PowerPoint. Before we go into analyzing our data, which we have for today, I would like to know, is there any questions? If there's any question, you can just go ahead and drop it in the chat box. I'll be going through the chat box right now. Oh, okay, Michael, thank you. Thank you. So, any questions, please, before I go ahead and go into analyzing our data set for today? Okay. If there's no question, then um, I'll just quickly go ahead and do this. So, the first thing we'll be looking at is so the first thing we'll be looking at is, or the data set we'll be looking at today is hospital readmission dataset. I'll be carrying out an extensive EDA on our hospital readmission dataset. Those steps we've looked at in our PowerPoint, we'll be looking at those steps today on this dataset, and we'll be going through each one of them. So this dataset is, let me just read the background. So we are working for a consulting company that is helping an hospital group better understand patients' readmissions. When we are talking about readmission, is okay, this patient has been treated, he has been discharged, and probably after few seeing these readmissions which we've been experiencing in this hospital, we want to find out and resolve. So the hospital has 10 years of their information on patients who have been readmitted to the hospital after being discharged. The doctors want you to this number of procedures or other variables could help them better understand the probability of. So the doctors want to be able to know what can help them to determine if a particular patient is likely going to be readmitted hospital. They want to focus follow-up calls and attention on these patients with higher probability of readmissions. So to tackle this, these are what we are going to be doing. First of all, we'll be importing our libraries, which we'll be needing. Then we'll be reading in our data set, the step through our data set, just do a brief look through, see what our data set is all about. Then we'll be doing an extensive data set where we'll be changing column names, we'll be correcting data types, we'll be We'll be dropping redundant columns, we'll check for missing values, fix inconsistencies. Then we'll now go ahead and carry out EDA, which is exploratory data analysis on our dataset. Remember that in EDA, all these steps, step 1, step 2, step 3, step 4, encompasses in EDA also. While for the step 6, we'll give insight and findings from our data and we'll write an executive summary of the project. Okay, so let's go ahead and do that. So this is our data, and before I load in this data set, or let me just go ahead and read that in. This is our packages we'll be needing. We'll be importing pandas as PD, numpy as NP, matplotlib.pyplot as PLT, and on as SNS. Now, after importing our packages, the next thing we want to do is to read in our data set, right? And to read in your data set, this is the file path to this data set. This is where this data set is saved in my computer system under the downloads aspect of my file. Okay, and the name of this data set is hospital underscore readmissions. Then the file is a CSV file, so we have to add the .csv as an extension to this, and using the pd.read underscore csv, we'll be reading in this data set into our Jupyter notebook for analysis. So with that, I called on the .add method and we're able to get the first 5 rows of this data. So this is the data set. This data set contains age, the amount of time a person has spent in the hospital, the number of lab procedures, the number of procedures this patient has done, surgical procedures. We have number of medications this patient has been administered during the stay in the hospital, the number of times this patient has been an outpatient, the number of times for inpatients, that means the patient has been admitted. Okay, outpatients, you just come in, you see the doctor recommends or administer any treatment, and you go back to your house that same day. But for inpatients, the patient was admitted into the hospital. Okay, the number of times the patient has been rushed to the hospital as an emergency case, medical specialty. Okay, what was the diagnosis? Okay, the medical specialty, that's the department in the hospital this patient was admitted into. Then we also have diagnosis. We have the primary diagnosis 1, which is the primary diagnosis, diagnosis 2, secondary diagnosis, diagnosis 3, which is tertiary or any other additional diagnosis. There are situations where a patient will be admitted into the hospital and the patient will have more than one diagnosis, right? Okay, so you can have more than one diagnosis. You might be having DM, but the main reason you were admitted is probably you were having an heart failure. Okay, so there are different diagnoses. We have diagnosis 1, diagnosis 2, and diagnosis 3. Then we also have glucose test. Was a glucose test carried out? Was the A1C test carried out on you? Was there any change in, we have this change column. I don't know. Let's check what the change column is about. Okay, this is it. Change, whether there was a change in diabetes medication. Okay, so was there any change in your diabetes medication? Is the patient on diabetes medication? And was this patient readmitted? Yes or no? Okay, so this is the data set we are going to be analyzing. And the first thing I said is after fixing in our data set, we want to go through our data set. Okay, so we want to go through our data set. Now we just use the dots here to see the first 5 rows. We don't know how many columns are in this data set. We don't know how many rows are in this data set. So this is what we want to find out. How many rows and how many columns do we have in this data set before you start any analysis, so that you don't know if you are working with 10,000 rows or 1 million rows of data and your system will just start hooking. So you just need to know how many rows and columns do you have in this data set, and you can use the dot shape method to do that. So calling out the dot shape attribute, you will see we have 25,000 rows and 17 columns in our data set. 6 columns in this data set. Okay, another quick exploration we want to do is to use the dot info method to give us a brief insight on this data. So we want to say, okay, Now we've known we have 25,000 rows and 17 columns, but we also don't know the names of those columns and what are their data types. So calling on the dot info method with this, we can get that we have these are the 17 columns we have in this data set. These are their various names. It also tells us the various data types. For example, we are seeing here that age is a string, and this is not correct. Age is supposed to be an integer because age is number, right? So we would have to change this. So you can see that using the dot info method, we're already seeing some corrections we have to make on this data set. We can see our time, no, amount of time spent in the hospital, and other. These are all the data types for each of the columns, and this non null can tells us how many non missing values you have in this data set. So it shows us that all our columns are correct. We don't have any missing values in any column. Okay, so it also tells us the memory usage of this dataset. Like this, we can see that with this dataset is 3.2 MB. Okay, so it just give us a brief insight, brief information on what this dataset is: number of rows, number of columns, the data types, are they missing values, what's the memory storage, and that's just what the dot info does for us. So once we go to data cleaning proper, and the first data cleaning we want to do is to rename columns. So remember that when we read this data set in, we have columns like, which is the diagnosis one, diagnosis two, diagnosis three. So for better understanding, I want to convert these columns. You can see how diag one is primary diagnosis, diag two is secondary diagnosis, diag three is additional secondary diagnosis, right? So I want to rename these secondary diagnosis, additional secondary diagnosis. We want to rename change to if to med change. Okay, we want to rename A1C test to HbA1c test. So these are some of the changes we'll be doing, and to do that you can just call on the dot rename method to do that. That's why Python, for me, I feel Python is one of the easy and sweetest programming language. It's very, very easy once you can understand the concept, what is all about. So for example, I want to change the names of this column, and all I have to do is to just say dot rename, meaning I'm renaming those columns, right? And just pass in columns and a dictionary that is going to take in the old name, which is the name you want to change from, to the new name, which is the name you are changing into. So is it not simple and straightforward? So I think that's just the easy way you can just go in and do that. Then you can add the dot in place equals to true to ensure that your changes stays in place. Okay, so that's what I did. The next thing I'll be doing after renaming, so if you look at this data set now, you can see that our changes have been done. We now have primary diagnosis instead of diag one. We have the secondary diagnosis, the additional secondary diagnosis for our A1C test. We now have the HbA1c test. For our change column, we have the med underscore change column. So we've changed those names of our columns we want to change. The next thing we want to do is to handle this column, the H column. You can see for the H column, it's taking 70 to 80, 17 to 80 as ages. It's as if it has already been categorized, but the categorization is not correct. We have to correct this. So instead of, let's say, 70 to 80, we want to, um give this a name. So let's say, for example, we can say 70 to 80 years is senior old age, 50 to 60 years is middle age, 40 to 50 years is early middle age, something like that, instead of just leaving this at 70 to 80. Okay, so that's the next thing we'll be doing. Why am I going to know how many different age would we have in this column? I have to use the dot unique method on this. So calling on the dot unique method on that age column, we'll be getting the unique values in that column. So you can see the unique values in that columns are 70 to 80, 50 to 60, 60 to 70, 40 to 50, 80 to 90, and 90 to 100. So we have 6 unique age in this data set. So now I can now go ahead and replace these values just like what we did when we were trying to rename our columns. But since these are values, or these are rows of values of data in our rows, we will not be using the rename, but we'll be using the replace. So you can see the difference between both. We'll be using the replace, and we can just replace this value. For 70 to 80, we'll be using the senior old age. For 50 to 60, we'll be naming this as late middle age. For 60 to 70, we'll be naming this as the mid old age. For 40 to 50, we'll be naming this as early middle age, and so forth. Okay, so this is how we'll be renaming these columns or rows of data. So you can see that this is quite different from you trying to create a category, because from the way this data set was created or fixed in, the ages have already been categorized. So you can see 50 to 60 years, it has already been categorized, just that they use numbers for their categories, and we want to change these numbers. Okay, so we did not actually do the categorization, but we changed the way it was being categorized. So now if you go ahead and check the type, the next thing I did was to check the type of this data set, or of this column, of the age categorical column, and I converted this to the category type, because we have now correctly categorized this column as an age category column, right? So that was what I did using the dot as type method, fixing category, and you can go ahead and, you know, change the type of that column. So if you go and check, use the dot d type to check the category of that column. Sorry. Now you'll find out that you have that column as a category column. And if you go ahead and read in that column and check those values in that column, you see now this is our previous column, which is age, and this is now the new age category column which we've created. Senior old age, late middle age, very senior old, and so forth. So since we've made those changes, you can now see that this H column is now redundant, right? Because these two columns are talking about the same thing, they are giving us the same insight, and this H column is no longer useful. So what are we going to do? We are going to drop that column from this data set. So we'll be dropping the H column from our data set by calling on the dot drop method. So you call on the dot drop, you the column you want to drop, and you specify that you want to drop along axis, which is column, and in place we have to add our in place argument as true, so that when you read in your data set once more, you see our h column is no longer found in this data set, but we can now see our h category column. Okay, so that's the method, or that's the way you can drop any column from your data set by just calling on the dot drop method. Let me see any questions so far. Okay. Um Okay, the next thing we'll be doing is to change data type to the correct data type. And some of those columns which we'll be changing are our medical specialty, because our medical specialty contains different categories of medical department, right? So we want to change it to a categorical column instead of it being just a string or an object data type. We want to change it to category. Our primary diagnosis that contains circulatory, diabetes, respiratory. We want to change that to category as well. Our secondary diagnosis column, we want to do that as well. Our additional secondary diagnosis, the glucose test column, the HbA1c. So these are all the columns we want to convert to category data type. So, and I told you previously that an easy way to do that is, what I have to do is, so that I won't do this and one after the other, I just have to pass all the names of those columns I want to convert into category in a list, and I will now be passing that name. So you could see the name of this list is calls to convert, right? So I'll be passing that list right inside our hospital DF data frame, and I'll be calling the dot as type method, specify the type you want to convert the data type to, which is category, and with that all our changes will be done. Just writing one line of code you've carried out your changes. So calling on the .d types, you're able to see that medical specialty is now a category, primary diagnosis is now a category. All our changes was carried out on those columns we wanted to change. Okay, so the next thing we'll be doing is handling missing values, and we'll be using the .isNA. You can either use the .isNA method or the .isNum method to check for missing values and handle those missing values in your data set. So this time around, we will be using the .isNA method. I'll be calling on the .sum method, and if we do this, you'll see that we have zero missing values. Like this is just going to confirm what we said earlier when we called on the .info method to check our data set, right? Where I said we did not have any missing values in this data set just by looking at the non-null count. So if you check this, you'll see we have zero missing values on this data set. So we have all zeros. But in situations where you have missing data, what are those things you can do? You can apply the general thumb rule. For example, you can look for features with less missing values, and if your data set contains features with less missing values, you can use regression to predict those missing values or fill those missing values with mean, the mode, the median, depending on the particular feature. If it's a categorical data, you can fill with mode. If it's a numerical data, you can fill with the mean. Why? For feature where you have high missing values, like when I say features, I mean rows of datas where you have high missing values, or columns of data where you have high missing values, you can drop those columns because they are going to give very less insight on the analysis. Then you can also decide to delete or drop columns if you have more than 30% to 50% of missing values, but you have to be very careful. I've explained this earlier. You have to be very careful when you are dropping data from a medical data, because some of these missing values might not be missing values. 'Cause like I explained earlier, for example, if you have should I say a discharge column is going to contain discharge, a date the patient was discharged, right? So if this patient has not been discharged yet, it means that column or that row of data for that patient is going to be empty. So imagine you're going to drop that row because the patient has not yet been discharged, because technically that's not a missing value, right? So imagine you're going to drop that row, you're going to be losing insight from your data set. That's why I said before dropping any row when you're working with a medical data, you have to make sure you check and ensure that those rows are actually missing values. So these are some of the things you can do when handling missing data in your data set. Another thing we are going to be doing, these are all under, remember, these are all under data cleaning. All what we've been doing is data cleaning. That's why I say data cleaning is one intensive aspect when it comes to analyzing data sets. You're going to spend majority of your time in cleaning your data set so that your insights are not going to be wrong. So the next one to do is to check for duplicates. And you can use the dot duplicated method, call on the dot sum method on it, and you can say we have zero duplicates in this data set. Then now we can go ahead and check for inconsistent data. I always hammer on checking for inconsistent data because these are things that you can easily ignore, and if you don't tackle them when you're cleaning your data, then you're going to be getting really, really, really wrong insights or values from your data set. Like I said earlier, for example, you can have the gender female saved in almost four different methods. You can save female as F, you can save it as capital letter female, small letter female. You can even have error in the spelling, and all these are all female rows of data, right? So imagine you want to explore just the female aspect of the data set, and you have four different types of values that have been saved as female already, you're going to be getting wrong insight. So you have to check that and correct it and ensure that they are all going to be using one spelling. So a very simple way I go ahead to do that is I call on the dot unique method on each column of my data set so that I can see the unique values in this data set before I can go ahead and clean it, right? So that's what I do. So I just wrote a short piece of code that follows through all the columns in the data set, and you call on the dot unique method on those columns. So for example, you can see the time spent in the hospital. These are the unique times. We have 8 days, 3 days, 5 days, 2 days, and so forth. For lab results, number of lab procedures, these are the unique number of lab procedures every individual has carried out. For number of procedures, we have 120635 and so forth. So this is just it. So for medical specialty now, you can say we have missing, order, internal medicine. So now, if there's any mistake in the spelling, or if there's any medical specialty that is appearing twice, I cannot go ahead and look at it and say, okay, probably there's a mistake here. Let me go ahead and correct that spelling and so forth. So calling on the dot unique method helps me to easily carry out those corrections. So looking through these data sets, you will see we have no inconsistent value. So I'll be going ahead. So another thing I love doing when working on any data each point, write out those things you've done. So for example, for data cleaning, my data set at the beginning was 25,000 rows. This should be 25,000, not 2,500. Okay, was 25,000 rows of data, and we had 70 columns. And I'm going to specify data cleaning. You can see I said there were no missing values or duplicated data in the data frame. I also specified that these column names, DAG1, DAG2, DAG3, and so forth, were renamed. And what were they renamed to? Primary diagnosis, secondary diagnosis, and so forth. So I'm going to be telling you what I did so that whoever I'm presenting this project to is going to see that, okay, this person actually carried out some work. Okay, so you could say also say for the age column, it was wrongly categorized, and I went ahead and I categorized it correctly. You can also see I said that the data type of these rows were wrong, and I also went ahead to convert it to a categorical data type. And I specified that at the end of the day, I had 25,000 rows of data and 17 columns. Okay. So this is me just giving a brief summary of those changes which I have done. So now we're going to go into EDA. Remember, all these things we have been doing are also part of EDA. Remember that in our PowerPoint we said EDA consists of you importing your data set, cleaning your data set, carrying out descriptive statistics, visualization of this data. So all these are all about EDA, feature engineering, and so forth. So the next thing I want to do now is statistical analysis. Remember I told you I'll be showing you statistical analysis. So an easy way to carry out statistical analysis on your data set when working with Python is just to use the dot describe method. That's why I love Python. It's easy and straight to the point. So calling the dot describe method is going to give us statistical analysis on all our numerical columns in this data set. So imagine you just writing one line of code and you're getting a whole lot of findings. So for example, you can see that for time in the hospital, the the least amount of time that was spent in the hospital was 1 day. The maximum amount of time spent in the hospital was 14 days. The average was 4.4 days. We have the median, which is the 50% value, as 4 days. We have the 25% quantile value, 75% quantile value as 6 days. We have for the number of lab procedures done, number of procedures, the number of medications, number of outpatients, that's the number of the least number of time a patient has been an outpatient is 0 days, while the maximum number of time a patient has been an outpatient is 33 times. Okay. For number of inpatient, number of emergency, the least patient of time or the maximum patient of time the patient has been has been taken to an emergency room is 64 times. Okay. So calling the dot describe just gives us that quick analysis on what this data set is all about. Now, the next thing we'll be looking at is we can also use the dot describe on categorical columns. The only difference is you just have to add this exclude equals to, you want to exclude numbers. You're telling Python that you can just exclude the numbers and just want to look at just the categorical columns. So calling on the dot describe, we're going to be getting the unique values in each category, the top values in each categories, and the frequently how a value is be frequented. So for example, for medical specialty, we have 7 different medical specialty. The top value is missing. That means there was no medical specialty and it's occurred 12,382 times. We have 8 different primary diagnoses. The most occurring primary diagnosis is circulatory and it occurred 7,824 times. Okay, so this is just what the calling the dot describe method on the categorical columns does. So, I also said for statistical analysis, another important aspect is visualization. With graph, it helps anybody that is seeing your analysis to be able to easily understand what you are analyzing. So we'll be carrying out visualization. So for example, what are those columns you want to visualize? We have the age categorical column, the medical specialty column, primary diagnosis, secondary diagnosis. These are all the categorical columns in this data set. I went ahead to write this out and make it in a list. Then I will be creating a function that is going to be plotting a count plot graph. So we want to see how many, instead of looking at this table, we want to look at a graph and see what are those values we have. So these are the line of code, sorry. Okay, so this is the line of code I went ahead to easily do this. sns.canplot, put in C, which is you see I for loop through C in columns. Columns contains a list of all the columns and pass act the title name as the column plt s ticks to help us to rotate our tick s tick values and plt dot show to show our features. So this is it for each category: middle old age and late middle age. Then we have the early middle age and the centenarians. We also have for medical specialty, the most occurring is missing. We have internal medicine, we have others, we have general practice, trauma, cardiology, and surgery. We have for primary diagnosis, the most occurring diagnosis is circulatory diagnosis, then followed by others. Then we have respiratory diagnosis. We also have digestive, diabetes, injury. Then we also have we don't have patients, or we have few patients with missing primary diagnosis. So that's just all this visualization is all about. So you can see it's different from creating a it's different from you creating a statistical analysis or creating a table that shows you these findings. Okay. Now, the next thing I want to do is to analyze our target variable. What is our target variable? Remember, we're trying to look at readmission. We want to see reasons why a patient is going to be readmitted or not. What are those things that can make a patient readmitted or not? So our target variable is readmission. So let's look at our readmission column. To do that, I use the readmitted HSPDF, passing readmitted into our columns and call on the dot values count on this. And I use the dot plot, and for example, if I go ahead and let me show you something, if I call on the dot values count on our readmitted column, it's just going to tell us how many patients were readmitted and how many patients were not readmitted. So for example, you can say we have 13,246 patients readmitted, that were not readmitted and 11,754 patients that were readmitted. So if I want to place this into a chart for easy visualization, these are the lines of code I went ahead to do this. And let's look at our charts. So if I click on this, you'll see our readmission chart, and it tells us that from this you can see that this is no, this is yes, and we can easily see that the patients who were not readmitted are more or slightly more than patients that were readmitted. Okay. So this is one important aspect of using graph is it helps you to easily see that insight you are trying to show your audience. Okay, so you can see I actually did this. I used the normalize equals to true, and you can see the percentage. 52% of patients were not readmitted, while 47% were readmitted. So from this, we can say our data set is a bit balanced because we have 52 to 47% ratio. And so now we'll be analyzing other data. Oh, now we'll be analyzing our data with other feature using our target values to get more insights. Okay, so how do I go ahead to do this univariate analysis? So now we want to carry out same analysis, but want to use our target variable to get more insight. So you can see if you look at this, you see that it's the same process I used earlier to create these these are analysis here. Okay, same process, but the difference now is that I'll be adding an additional value of u, and this u is going to be our readmitted, which is our target variable. We want to analyze these same columns of data, but we want to see it based on if a patient was going to be readmitted or not. So for example, for the age category, you so for example for this age category, we can see that senior old age, um, we had more people who are not readmitted to patients who were readmitted. So you can see a brief and change, but it also tells us that a lot of people who are going to be readmitted are going to be senior old age. Okay, so you can also see that for middle old age, more people were admitted from the middle old age, but we had more people who were not readmitted to people who were readmitted. So for example, if you look at this very senior old, you can see that there's slightly no difference between people who were readmitted and people who were not readmitted. For late middle age, we would see that um, more people were not readmitted compared to people that were readmitted. So this is just going to give us insights based on if a patient is going to be readmitted or not. So you can see for missing, it contains more people were readmitted, but remember that these are missing values also contains a larger aspect of our data sets. So this is how you can go about, analyzing your data set based on your target variables. These are different plenty insights you can go ahead and get from this data set. Okay, so I'll just go ahead and scroll through this and go to the next thing. The next thing is age group versus readmission. We want to see relationship between age group and readmission. So okay, sorry, we've already done that. From our age group and readmission, we could this is the information or insights we got from it. We said certain age group, particularly 60 to 70 years or 70 to 80, which we've regrouped, show higher readmission rates, while younger and older extremes have fewer readmissions, possibly due to smaller patient count or different treatment pathways. So the next thing I want to do is to, look at those or segment our data by looking at just those patients that are readmitted. So how do I go about to do that? I I'll be calling the name of our data set, which is HSPDF, and the column which we're trying to get is this column, which is the readmitted column, right? But we want to return only rows of data where the readmitted column is yes, and we want to be saving this as the readmitted underscore data. So if you go ahead and look at this column, you will be seeing that on our readmitted column, we only have yes, 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 yes. Okay. And what do I want to use this column to do now? I want to use this column to I want to analyze this data set and see what percentages of patients were readmitted for each columns. Okay, so if I go ahead and click on this table, you'll be seeing for senior old age 28% were readmitted, middle old age 23%, very senior old age we have 90%. So this just gives us the percentage of each categories of data for each columns that were readmitted. Now we're just looking at only just the readmitted rows of data. So that's what this is going to, give to us. These are the insights we can get from this. So you can go through this at your spare time and, find out more insight from this. Now, the next thing I want to do is to convert our readmitted column to numerical columns because I want to create an heat map that shows me relationships between patients who were readmitted and our numerical columns in our data set. To easily convert our numerical, our category to easily convert our readmitted column to numerical columns or numerical values, I use the np.where function and I'll be passing in that column, which is our readmitted columns, and specifying that where yes, anywhere we have the yes values, let that be 1, and any other values should be 0. So meaning no values are technically going to be converted to 0. Okay. So and I'll be saving this new column which I'm creating as our readmitted numerical column. So with this, I'll be using this new column which I've created to create a heat map that is going to show me the correlation between our target variable and our numerical columns in this data set. So I use the sns.heatmap, passing our data frame, which is hsp_df. I'll be using the .corr, which is the .core function that talks about correlation and passing all our necessary values. So you can see now that it shows me an heat map, and this heat map is going to show me relationship between the readmitted column, which is this column, and our numerical column. And for looking at heat map, the darker the color, the more relationship those two columns have together. So for example, if you look at our readmitted column, we have our inpatient is more a bit darker. You can see this is a lighter shade of yellow. We have this is a bit greenish, which is darker. And if you look, this is the column we are focused on, right? Or let me scroll through this and okay. So this is the column we are focused or this is the row we are focused on, readmitted column. So this is readmitted and time in hospital, readmitted and number of lab procedures done, readmitted and number of procedures, readmitted and number of medications taken, number of outpatient, number of inpatient, number of emergency, and readmitted and readmitted. Any two column related to itself is going to be at 1. Has a very strong correlation. So this does not really matter. So the column which is much more related or correlated to the readmitted column is our inpatient column, which is 0.2. Here we have a slightly, we have a slight relationship, positive relationship between number of times a patient has been an inpatient and readmission. So a patient who is admitted is much more likely to be readmitted. So we also have number of outpatients. We have 0.095. We also have number of times patients have been brought in through the emergency units. Okay, so this is the insights we can get from our heat map. So you can see for our summary, I said we can notice that the heat map shows a weak correlation between the number of inpatients and readmission. So the next thing we're going to be doing is to carry out feature engineering. And for feature engineering, we are going to be pre-processing our categorical columns using pd.getDummies. And we just want to change categorical columns to numbers or, yeah, that's what we want to do. because we'll be using those values, our numerical values, to be able to, you want to just look at the correlation between our target variable and just our numerical columns in the data set. Now, we want to look at relationship between not just our target variable and numerical columns, but both with those categorical columns or object columns in the data set. So that's how we want to, carry out feature engineering. So to do that, we have to use the pd.getDummies, pass in. What I did here was to drop those columns which I will not be using. So just pass in your data set and specify, just pass in your data set, the name of your data set, which you want to, carry out your feature engineering on. And technically, or what it's just going to do by default is to, convert those categorical values as zeros and ones. So you can see our primary diagnosis, we now have primary diagnosis circulatory as one, where we have primary diagnosis be zero if it is not. So this is what technically is going to be happening in our feature engineering. So you see that are now numbers. So now we want to be using these values or this data set, which is our dummies data set, and we want to be creating a bar chart from this to tell, so that we can see, instead of using a heat map, I want to use a bar chart so that I can easily see the relationship. So you can see that from calling the .com method on this our dummies data set, and we are passing our targets underscore norm sort values so that we have a sorted bars, and we also specify that our plot should be a bar chart. Okay, so from this we can now easily see those columns of data that are correlated with our readmission value. So we can see inpatient, this is just supporting what our heat map said earlier. So our heat map, we said the columns of data that was more correlated with readmission was inpatient, outpatient, and emergency, right? So you can see for this bar chart, it's telling us same thing. So inpatient, let me go ahead and scroll this more. So you can see we have inpatient, the outpatients, emergency. Then if a patient is on diabetic medication, is another column that is correlating with readmission. Okay, so columns that are not relating to readmission, patients that are not on admission, the number of surgical procedure does not matter, if a patient medication was not changed, and so forth. So this just shows us columns that you can use to predict or that correlates if a patient is going to be readmitted or not. So let's move ahead. The next thing we're looking at is our bivariate analysis. And for bivariate analysis, it's just analyzing two columns of data in your data set. So what we want to look at is we want to analyze the amount of time a patient spent in an hospital and readmission. Okay. So looking at this, we can see that there's no particular, it doesn't really, okay, before I do that, I use the bus plot to be able to create this chart. So SNS does bus plot, passing the name of my data frame, which is HSP underscore DF, the names of those two columns which I want to look at, readmitted and time in hospital. PLT.title to add the title of this chart, and PLT does show to show us this chart. So you can see that if you look at this chart, both patients who were readmitted and patients who are not readmitted are same. There's no difference between this chart and this chart. So time, the number of time a patient spent in the hospital does not really tells us any much information if a patient is going to be readmitted or not. So that's what practically this chart is telling us. A number of time a patient spent in the hospital does not determine if a patient is going to be readmitted or not. Okay. Then another thing we can look at is patient and readmission, inpatient and readmission. Remember when we looked at our charts, when we created the heat map and the bar charts to show correlation, inpatient was a very top features to predict if a patient is going to be readmitted or not. So we want to analyze those two columns, inpatient, if a patient has been admitted, and if a patient is going to be readmitted. So we same process, I use the bus plot, passing the name of the data frame, and use specify our x and y variable, which are those two columns we'll be looking at. So if we look at this, we'll see for patients who were readmitted, yes, it has some values, and it also tells us that patients that spent above 2 days are more likely to be readmitted. You can see, and we also have some outliers, okay? But patients who has who the admitted time were low were not likely readmitted or were not readmitted. So if we look at our summary, we could see higher patient visits are more common among patients who were readmitted, and this could indicate chronic or recurring health conditions. So it's stating that what's technically saying that before you are going to be admitted, it means you already had a chronic condition or a recurring health condition. So this is most likely going to mean that definitely you are going to be readmitted back into the hospital system. The next analysis I'm going to be looking at is analyzing patients on diabetic medication and readmission. So are patients who are on diabetic medication going to be readmitted? So that's what I want to do. So I'll be using a cant plot this time around and passing in the name of my data frame, which is HSP underscore DF, two features which we are looking at, diabetes medication, and we'll be using the U parameter as readmitted. So now if we look at this chart, we can see that patients who were on diabetes medications, um, see, we have our values, our colors, blue as no, yes for orange, no diabetics, yes for diabetes. And we can see that patients who were on diabetic conditions are readmitted and also occupy larger patient of patients or larger values of patients who were not also readmitted also. Okay, so if we go ahead and look at the summary, I said patients on diabetic medication appear more likely to be readmitted, reflecting on the chronic nature of the disease condition and risk that is associated with diabetes management. So these findings are just to back up what we got from our correlation. So you could see we have, okay, okay. So you could see we have inpatient, outpatient, number of emergency. If a patient was diabetes medication was changed, yes or no, and if a patient is on or on diabetes medication, these are columns that were more likely to determine if a patient was going to be readmitted or not. So these are some of the analysis I carried out on this data set. You can go ahead and carry out more analysis on this data set if you want to. I'll be dropping the data set on the description to this video. So in case you want to, do your own private work or carry out more analysis, go more further into this, you can go ahead and do that. So this is all for this. Any question? Is there any question? I'll be going through the comment section now to see if I have any questions. Okay, thank you. So is there any questions? Hmm. So please, if you go through and if you watch this video, please ensure to subscribe to this YouTube channel. I'll be dropping more content relating to analyzing healthcare data.